Hello guys, welcome to my channel Civillogy, the study of civil engineering. This video is about designing of a beam. In one of my previous videos, I made a detailed video about how to design or how to find breadth and depth of a beam by thumb rules. In that video, I discussed about the Indian standard codes and ACI codes for determining the depth and breadth of the beam. So this is again the same question but a bit different, okay? But in this situation, as you can see over here, the beam is subjected to UDL and a point load, and they are asking us to find depth and breadth. So let's start our today's topic, that how can we find breadth and depth if such situation is given. First of all, let us assume an example that find the suitable size of the beam as shown in the figure. The breadth of the beam is to be kept 0.4 depth, okay, 0.4 times depth. Here is the restriction. The restriction is that the breadth should not exceed 0.4 times of its depth, okay, and the stress should not exceed 8 multiplied by 10 raised to the power 3 kilonewton per square meters. But we start the designing of the beam. Here are most important things which I have to tell you, that as we can see over here, the beam is symmetrically loaded and simply supported beam, and for such type of beam maximum bending moment is given as, for point load the maximum bending moment is given as WL divided by 4, where weight W is the point load and L by 4 is the distance, okay. And for point load at mid span, as you can see over here, the beam is subjected to point load and the point of application is at mid span, okay. So for such situation, maximum bending will be equal to WL divided by 4. This is the shortcut formula. Otherwise there are lengthy procedures to calculate the maximum bending. I have also made the detailed videos about how to calculate and how to draw shear force diagram and bending moment diagram, the link of which is given in the description. Also watch those videos, okay. And similarly for UDL, if the UDL is on full span, then maximum moment is given as WL square by 8. So these are the formulas which you will have to remember for such conditions, okay. Now proceeding towards next step, and here for simplifying this equation or to cater with these type of equations and these type of situations, we need to use bending equation or flexural formula, okay. Flexural formula is equal to M divided by I is equal to F divided by Y is equal to E divided by R. Now M is maximum bending moment, I is the moment of inertia. What is moment of inertia? The link of that video is given in the description. Please watch that video to understand what is moment of inertia. And small f is bending stresses at distance y from neutral axis, okay. And E is the Young's modulus, and R is equal to radius of curvature of the deflected beam. As we know that when the load is applied, the beam shows deflection, okay, such type of deflection. So this distance is called as R. This is radius of curvature, okay. So now proceed towards next step. This was the example for which we are going to use the flexural formula for determination of depth and breadth of the beam. The beam is subjected to a point load which is 400 kilonewton and a UDL which is 50 kilonewton per meter, okay. So by fetching the given data from the given question, let us assume that depth of the beam is equal to D, okay. And let's assume the cross section of the beam, and this is the neutral axis. As we know that the center or centroid, the line passing through the centroid of the section is neutral, is called as neutral axis, and top of the beam experiences compression, whereas bottom fibers experiences tension, and the center point, which is neutral, is called as neutral axis or zero line. Okay, and this is the depth of the beam, and breadth B of the beam is equal to 0.4 times D, as we have a restriction over here that the breadth of the beam is to be kept 0.4 times of depth. Okay, and the point load is 400 kilonewton, UDL is 50 kilonewton per meter, and maximum bending stress is given as 8 multiplied by 10 raised to the power 3 kilonewton per square meter. Okay, so we are going to use this formula. Very interesting thing about this equation is that you can use either pair for determination of unknown variables. Okay, you can use either first two pairs, as you can see over here, or you can use the last two pairs, or you can use the first pair and the last pair at a time to find the unknown variables. So if we look at the given data, we are given F. Okay, and the remaining things will be determined as we are proceeding. Okay, first of all, we will have to find maximum bending moment, and it is equal to, as I told you in the start of the lecture, that for UDL it is WL by 4, and for point load it is WL square by 8, and this beam is subjected to both point load and UDL. So it will be the maximum moment will be equal to the sum of both for point load and UDL. Okay, and by putting values, as you can see over here, 400 is point load, and length or span of the beam is 8 meters and divided by 4. Similarly, 50 is the UDL, 8 is the span, and dividing by 8 is in the formula. We will get maximum bending moment, which is 1200 kilonewton meter. Okay, now to find y, as you can see over here in this formula, we will need to find the y. What is y? Y is the distance of extreme fiber from neutral axis, as you can see over here in the cross section. So the half of the depth of the beam is called as y. So y will be equal to d divided by 2. Now the next thing we need to find is I. Okay, the m is we have calculated already, and we have already find y, and now we are going to calculate I. Okay, I is moment of inertia, and for rectangular section, moment of inertia is equal to bd cube divided by 12. Okay, by putting values, as the value of b is 0.4 times d, then d cube divided by 12. Okay, so it will be equal to 0.4 d power 4 divided by 12. Now as we are using this equation, and in this question we are going to use first two pairs for determining depth and breadth of the beam. By putting values, as we have calculated the maximum moment, which is 1200, I is equal to 0.4 d power 4 divided by 12, and it is equal to F. The stresses in the beam is given in the question, and it will be equal to 8 times 103, 8 multiplied by 10 raised to the power 3. Sorry, this 3 is in power of 10, and y is equal to half of the depth of the beam. So by simplifying, as you can see over here, the 12 will multiply with 1200 and it will be equal to 36,000. Similarly, this 2 will be multiplied with this value and we will get this equation, and by simplifying this value, it will be equal to, the d will be cancelled out with this 1d, and we will be left with d cube. Okay, and d cube will be equal to 36,000 divided by 16,000, and by taking the third root we will get the value of d, which is equal to 131 centimeter or 1.31 meters. Okay, so now it has simplified, as we know that b is equal to 0.4 times of d. By putting the value of d, we will get the value of breadth, which is b, and it comes out to be 52.4 centimeters. So that's how in this situation you can find the depth D and breadth B for a given cross section of the beam under the given conditions. So that's all for today. In the end, you are requested, if you are new to my channel, please subscribe it and don't forget to press the bell icon to get video updates. That's all for today.